Hello, let's discuss how we can use Apache SystemML as a machine learning tool through Jupyter Notebook in data science experience, the DSX. You are looking at a GitHub repository where this exercise exists. This is the README file which shows all the instructions starting with how to set up your DSX account or create any new Apache Spark instance if you need to, and import Jupyter Notebook in the DSX using this URL. Once you have imported this one, imported this notebook in the DSX, it will look like this. Let's walk through what this notebook contains. Before going there, what is Apache SystemML? Apache SystemML is a machine learning tool which provides multiple options to data scientists to do machine learning. It contains set of CAN algorithms which data scientists can use as it is or customize them per their need, or write new algorithm using declarative machine language which has R or Python like syntax. When data scientist writes an algorithm to run using SystemML, he or she doesn't need to worry about runtime environment or scalability of the data. SystemML has inbuilt optimizer which will generate runtime plan based on data characteristics and runtime environment. So this notebook contains like a sample script which will be similar to how you can write your own algorithms. It contains one of the algorithm described where you can use out of box like a CAN algorithm like linear regression, and it will show different flavors of linear regression algorithm you can write or customize one of the algorithms very naively. And last but not least, it will show how you can use linear regression through scikit-learn type interface. Okay, let's walk through. Since this is a DSX, it has SystemML already configured. As of now, it has, if you look at here, it shows version 0.14 when we speak. Next is how you can do the scripting, right? Like a basically part of the algorithm. Here it shows there is a X, which is a matrix initialized with a number of rows specified and columns. Then you do matrix multiplication, basically transpose of X into X, and then sum of all cells, which is assigned to S, and then you can pass that script to the DML object with the input parameters and expected output parameters. Then you do the execute part with a passing program as a parameter, which is a DML, and then get results and print it. It's as simple as this one. But there are a lot of operators and functions available. We can walk through the language reference guide, which you can use once you decide to write your own script. So there are multiple CAN algorithms already provided to SystemML. One of them is linear regression. If you look at here, I'm using a dataset, a diabetes dataset from scikit-learn, and this is the only dataset I'm going to use throughout this exercise. I divided this into train and test with a very naive approach, but data scientists should know much better approach than this one, basically randomize or etc. And you can divide your dataset into train and test. This time I'm using linear regression DS, one of the CAN algorithm, and then passing it as an algorithm with the trained dataset with input parameter and expected output parameters. Then I use execute that program to get the bit out. Once I get that one with a weight and bias, I can use this to predict my future output based on the test data. Let me plot this data set. Black points are the training points and red are the test points, and this blue line is basically the model which can help you to predict the result based on the test points or any unseen points. This is how it will look. This is from the CAN algorithm. Let's write a similar algorithm via handwritten scripts. Let's look at it, how it looks. Here, I'm using the direct solve, just like earlier one, same data set. If you look at here, X has been defined, then matrix A has been calculated with the transpose of X into X, then B is computed with the transpose of X into Y, and then W has been computed with the solve method by passing A and B, and then we get a result of bias and W. So this is a script. Let me then pass that script just like earlier example, where earlier we passed the existing script written like a CAN algorithm. Here I'm just passing whole string itself and passing the data set and expected output parameters, W and bias. Once I execute it, I get a W and bias, and then I can use to plot it. You can see it, the plot is similar to what I see when I run it through the CAN algorithm. Okay, so this is exactly what I have seen through the CAN algorithm. Let's twist this script a little bit to get another flavor of the linear regression. Next one is a batch gradient descent. What we do here, we initialize the weight, then we compute the gradient, we compute the step size alpha, then we update the new weight using the alpha and gradient, and we iterate through it until it converges. For sake of this exercise, we are iterating only up to 100 times, but it's up to individual data scientists how much time they can use it until converge, or what are the limit they want to specify. But this is again script. You can see it, it is little bit quick, but this can be direct solve is converted into the batch gradient descent. You use this script, again pass it to the DML object, execute it, get the W and bias, and plot it to display the results. You can see result is similar. Now which flavor to use is up to data scientist based on the data characteristics and expected results, right? Let's look at another flavor like linear regression conjugate gradient. What is the approach here? Again, we initialize the point, then compute the gradient, compute the step size alpha, then we compute the next direction of P by enforcing conjugacy with the previous direction, and then we update the W. Again, here we iterate through it until it converges. For sake of this exercise, we iterate only up to 100 times. You can see the data set is again same. Script is defined here with little bit minor tweak based on the how you want to tweak the algorithms or how you want to do the adjustment to your algorithm, and then pass it on to the DML object, execute it, get the results, and plot it. Again, you can see the similar results. Again, data set is same, probably result is same, similar, but again, it's up to data scientists which flavor of the algorithm or how much they want to customize. Purpose of these three flavor showing you is how easy it can be through SystemML. You write algorithm once and customize it so easily that you don't need too many changes to be done, and this customization can be done very easily. Okay, let's change gear a little bit. So far what we see, we wrote the script, pass it to the DML object, execute it, and get the result. Most of you are familiar or more conversant with the scikit-learn approach. What scikit-learn does, it allows you to instantiate the object which is nothing but one of the algorithms, say linear regression. Then you call method called fit to train and predict for scoring purpose. Similarly, for SystemML, we have some algorithms have similar interface like linear regression, where you define object, then pass the data set, call the fit to do the training, and then you can pass call the predict with a test data set to do the scoring. Okay, so initially I said let me show you how the language reference guide is there, where if you decide to write your own algorithm, you can reference to that one to use various functions or operators to write your own algorithms. Let's go here. This is a Apache SystemML.org site. This is a home page. Go to the docs, go to the latest, and you can see here there is a language reference. It depends upon which syntax you are using. You can go to one of the section and see what are the additional functions available so that you can write your own script. I shown one of the example of ML machine learning algorithm, linear regression, but there are a lot more defined. You can go to the ML algorithm section, go through this section and see what are the additional algorithms. You can use it here. I shown the current example I showed through the DML, through DSX notebook through DSX, but you can set up your own Jupyter notebook as well. You can go to the again homepage and you can see the get started, and you can see install SystemML, where it shows how you can set up your notebooks through Python or Scala and run this notebook through it as well. As well as you can see, there are various sample notebooks defined. I shown one of the example. There are various sample notebooks defined here. There are more sample notebooks available in the GitHub repository of SystemML as well. This example shows how you can run SystemML through Jupyter Notebook. There are additional interfaces available, how you can run SystemML, and those are again shown in the documentation side, where you can see you can use Scala REPL to invoke SystemML call. Again, documentation is available here, or you can use PySpark to do the SystemML calls. You can submit a job through Spark Submit or through Hadoop. You can run it through the standalone, or it has even Java interface available through JMLC as well. And this is not all. I mean, there are a lot more available here. I cannot. You can subscribe to Dev channel, Dev mailing list, Dev at systeml.apache.org, and you can get constant update. Or you can even contribute to the Apache, and help will be provided to contribute to the Apache system. That's all I have for today. Thanks for your time.